I hope we are live, guys. If you can hear me, just give me a heads up. Say hello in the chat so that we can start. Okay, I can see there are 15 people. Guys, if you can hear me, just give me a heads up. Just say hello in the chat so that we can start off with the session. All good, perfect. So let's get started. I can see there's 20 people who have joined us. So let's not waste time because we have a lot to discuss today. You will see that in few minutes. So without wasting any time, let me get started with the introduction of the session. I hope my screen is visible to all of you. All right, then. I welcome you all to the live video SDK mobile system design workshop. And in today's workshop, there are a lot of, speakers, not a lot of speakers. There are a lot of people who would be contributing to the session. There are some people who are working behind the scenes. There are some people who you would be seeing today. So big thank to all the team members from Swift Anytime and Stream to making it happen, and to you guys who actually showed interest in this session and are joining it today. So our event partner, we want to give a huge shout out to Stream for doing this with us in the partnership. Getstream.io, you can check that out. It's a live video streaming SDK that has chat feature as well, and a lot of other features too. But for that, you need to go to getstream.io and do give it a sign up and explore all the features that Stream offers. Then we have some host and the guest speakers. First off, we have Ahmed, who's a senior iOS engineer at Cafu, and he's my co-host for today's session. Then you can see that it's me, your host that have been there for all the other sessions that we have conducted, and I'm the co-founder of Swift Anytime, for those who do not know me. Then we have a special guest speaker with us today. His name is Yuran Linards, and he's a manager of developer relations at Getstream.io. And Yuran will be taking you through all the nitty gritties of how a complex system like Live Video SDK is built and how they approached Getstream, like the Stream SDK, and what are the challenges that they faced at Stream. Let me give you a brief outline of what you can expect from the session today. So this is a table of content. The first is the introduction of live video streaming, how the whole space works. Then we'll be talking about low latency, resource usage, and adaptive streaming. Then you have client and server side architecture. So we'll be discussing certain details of how this architecture works completely. Then we will be talking about the stream video SDK, how we have approached building this one, and what are the challenges that Stream SDK has itself faced while scaling. And at the end, if the time allows, we would like to have a 15-minute Q&A round. So without any further ado, I would like Ahmed to first introduce himself, because Ahmed has joined us some weeks back at Swift Anytime, and he's a new member, and it is his first time co-hosting an event. So I would like to invite Ahmed, and Ahmed, if you don't mind, introduce us. You can feel free to introduce yourself.
Thank you so much, Mayank, and hi everyone. My name is Ahmed Al-Gandhi. I am a senior iOS engineer at Cafu. I have spent the last 7 years crafting mobile apps that service millions of users, including my experience at Delivery Hero and Talabat. Also, I am passionate about building the apps and teaching the iOS development. So I published 2 courses in Coursera, where I am teaching how to build the networking layer in Swift and how to build adaptive UI in Swift. I am interested also in mentoring people, so I am mentoring developers in ADP list from different countries. And recently, as Mayank said, I joined Swift Anytime, and I am so excited today to co-host this event where I believe that we have a very good session with Jiron sharing his deep experience in today's topic. Thank you all, and welcome again.
Awesome, Ahmed. Thank you so much for co-hosting with me this today. Now it's time to introduce the guest speaker, the special speaker, the iOS expert of the day. That's Yuran Linards. So, Yuran, I will be bringing you to the stage. If you don't mind, can you introduce yourself to our iOS community? I know a lot of people already know you, but for them who don't, please feel free.
Yes, some people might know me. Um, First of all, my name is Jeroen Leenaerts. I'm from the Netherlands, so it's a Dutch name. So if you have some difficulty pronouncing my name, that's fine. Because the J is a bit weird for most people because we pronounce it very differently in the Netherlands. Second of all, don't let the title manager scare you because, yes, I am officially a manager within the developer relations team at Stream, but it's a very technical role. And I've been a software developer since 2002. Did like 9 years or 10 years of Java development and then switched to iOS development back in the day when you had, I think it was iOS 3 or iOS 4. Worked at some very big projects in the Netherlands, comparatively, of course, because it's not big tech level, but still millions of users. And well, through some job changes, I ended up at Stream in the developer relations role. And within Stream, I progressed from just a developer relations team member to actually managing the developer relations department. Next to that, I organize Cocoheads NL. That's like a meetup group in the Netherlands. We have like 1,500 interested people in the Netherlands. Probably for Indian standards, that's quite small, but for Dutch standards, it's quite big. On top of that, I organize a conference again this year in November, Do iOS in Amsterdam. You might heard of that as well. So I'm gonna announce the CFP anytime soon. Just look it up online. And what else? Yeah, I used to do a podcast, App Force One, but I just don't have the time to actually keep doing that because putting together episodes is a lot of work. And yeah, my main job is working at Stream in the developer relations role. So yeah, I've been doing iOS development for 10 years and still doing it, still going strong. Swift is different. I really liked Objective-C, but I like Swift as well. So the session today will be a very high-level technical walkthrough of what it would take to implement a video streaming service. If you want to get to the nitty-gritty details of what WebRTC is and a lot of those details, there's some resources at the end of the session on the final slide, and I'm sure that Mayank or Gandhi will be able to share those links as well. And so yeah, it's going to be a lot of basic information, but it should be a good stepping stone to get started if you want to dive more into this subject matter. And of course, I hope to convince you that creating a video backend or a video service or a video implementation in your app is not a small task to undertake, and that you might consider getting involved with a service provider for this. And we just so happen to provide such a service. So I always like people to do an honest comparison with whatever they do. So I hope that at the end of this session, you might have some interest in looking further into video streaming, into live streaming, and maybe even in our video SDK that integrates very well with our chat SDK as well. So that's my intro thus far. So let's get started, right?
Yeah, awesome. Yuran, please feel free to go ahead.
Yeah, I've got my slides here, so if you can put those on screen, we can kick things off.
Perfect.
So the topic of today will be live video SDK system design featuring the Stream SDK. So what this means is that I will be telling mostly about some of the things and how they are implemented at Stream. Why is this interesting? It will show you what it takes to actually be able to do a video backend for your apps or for your websites. We also have an SDK for websites, of course, but this is an iOS and Swift focused group. And the thing is with video is people think it's quite simple. You just hit play and there's like something playing on your screen and that's all you have to do. But imagine being two people in a video call. There's already two video feeds that you need to get at the right location. And this progressively gets more complicated if you are with 3 people or with 5 or 10. It's a factorial problem actually. So it's something that quickly becomes very complicated and also requires a lot of bandwidth and a lot of technical infrastructure to get things going. So why is video streaming important? That's the first thing I want to talk about. And then I want to dive a little bit into how we set up our video SDK for iOS. This involves a bit of the technical infrastructure on the server side. And hopefully I will give you a brief overview of how we architectured our SDK, because that's, I think, a very good template for you to actually explore this as well. And best of all, the SDK that we have available is available as a project on GitHub, and all the source code you can just open up and look at. And if you're interested in this subject matter, feel free to just explore and figure out for yourself how things are exactly implemented. And then, of course, we have a bit of a demo or a walkthrough, and we do a question and answer session at the end, because there's bound to be a lot of questions once I'm done with my slides. I don't have too many slides. I have like 26 slides remaining right now, but there's plenty to talk about. So setting the stage, why does video live streaming matter? The thing is, there are some things happening in this space, because if you look at some of the trends that are happening, and also the technical aspects that are there, but then there's also some things that are unique to iOS developers, because you can imagine if you have your phone or your iPad, a mobile device, and you need to make sure that someone can do video calling with that, that's all fine. But you don't want to be in a situation at the end of the video call that half the battery is drained of this individual, because I don't know about you, but if I use an app and I use it for like half an hour and then like 50% of my battery is gone, I'm not happy. And I reckon that your end users will also not be happy if that happens. So we will touch upon that as well. So some of the trends that you're seeing in video live streaming right now is that more and more companies are getting involved with video in some capacity. So it's not only like having like product videos next to like an e-commerce page. So you're in a shop and you want to buy something, you want to see this thing move in the videos, some person handling a gadget or a device. But also there's like integrations that you can do with e-commerce, that there's actually an actual person interacting with you if there's any questions that you have with your shopping experience. And also, it is something that is developing right now. So what we're seeing is that a lot of people are investigating if video should be a part, live video should be a part of their product, of their offering. And we're then more than happy to help people achieve that goal. But what you're also seeing a lot right now with these videos is that a lot of the content that is being published right now is short form content. So you can imagine that you have TikTok, you have YouTube Shorts, and that's all fine. That's like video that is recorded and then published. But also what we're seeing in our product and our platform right now is that there's like a lot of short sessions. I think there is one of these friends apps available that you can like ask people to share what they are doing right now, and then you quickly connect. You have like a short video call basically, and then you disconnect again. So, and another one is what's happening here right now is like the enhancement of interactivity and community engagement. So what that means is that, how should I explain this? Not only do people want to be able to connect with each other by watching something, but they also want to interact with each other within the audience. And of course, Zoom is a very nice example of this, how this could work. You know, you have like a big meeting with like 50, 100, 200 people, and then somebody presses a button and you end up in a sort of a conference call with 10 other individuals of the larger group, and you have some assignment and you need to you need to figure out some problem, for example. And this is something that it looks quite simple as an experience. You're just sitting in front of your computer, something happens, and all of a sudden you're in a sort of a video conference setting instead of a live stream setting. But making these transitions, making sure that everybody ends up at the right location and everybody is still connected, that's quite challenging. And of course, I don't want to mention it because it's the elephant in the room lately. That's the integration of AI. What we're seeing more and more, it started with our chat product, is that and you probably as an end user, but also as a developer, have noticed it on websites online. You have like these little bots in the bottom corner, and the first touch point you have through this chat interface is actually an automated process. You type something and you get some feedback. Now with the advent of large language models, these responses that you're getting are way better because they're contextual and they actually contain a lot of information that is relevant, hopefully, to you as an end user. But also what we're seeing now more and more is that in video live streams, you want to be able to integrate with an AI as well. So we are actually actively exploring if it would be possible to have, first of all, generated audio as a audio call participant, but also to have a generated representation in a video call. So that would basically be an AI generated participant in the call. So you would actually see something that resembles a human being. They're actually interacting. They are responding to what is being said over audio in this video call. And that's also a development that we're seeing right now. And that's actually quite interesting to see those kinds of things. But all of these things are like video based. So there's a video feed going out. Somebody is watching that video feed and they're sending most of the time a video feed back. So not the typical live stream setting that we have right here, right now with this session of Swift Anytime, but also 2 people, 10 people, 100 people, all interacting with each other. And I think that's a very interesting space to be in. There's a lot of things that are still to be explored there. And hopefully at the end of this session, you might come up with some ideas of something that would work with video, whatever platform that you're using, whatever implementation you're using, but something that would work for your case, so that you can actually start playing with video as well. Because not only is video complex, technically, it's challenging, but it's also very much a lot of fun because the level of interaction that you can achieve with users of your product is so high. Actually being able to look each other in the eye face to face and to be able to interact in that fashion instead of through a text-based chat-like interface, it makes such a huge difference, I think. So let's just start looking into some of the technical bits. So first, before I go into the client-side bits, I will touch upon the server-side bits a little bit because, to be honest, the client side of a video conferencing setup is actually pretty much the simplest thing to achieve. The code might be complex. There's a lot of stuff happening, of course, on your mobile device or in your web browser. But what's happening on the backend, on the server side, that's like a whole nother level. Just for reference, Stream right now, we have like AWS that we use as a compute provider. So we have like EC2 instances and who knows what else, because I've had a bit of a deep dive with one of the infrastructure engineers, and what he was showing, I was actually blown away, because Stream runs on over 1,000 instances in some way within EC2 on a global scale. So one of the aspects that we're going to look at is something which is called an SFU. I will tell you more what that is a little bit later, but it's a service that we run across the world in all the regions of AWS, and just in India alone, last I checked, we had over 40 of these instances running, and each of these instances was a C6 large instance of Amazon. Might not say anything to you, but one of these instances is a 3.3 gigahertz virtual processor with a 16 gigabytes of RAM. and of course some storage attached to that. But imagine having 40 of these virtual computers just running in the Indian region to make sure that everything can connect to each other and have a proper video call, not only in that region, but also across the world with other regions that are connecting to their respective endpoints within our global infrastructure. So server-side architecture, there are a few things that are important: scalability and load balancing, real-time data processing, content delivery, security and data optimization, data integrity, resilience and failover strategies. I cannot touch upon all of this right here. Just know that this is all stuff that you need to think about if you're implementing the backend of your video infrastructure. So why is the scalability and load balancing of course important? You need to make sure that if one person connects, that the performance is good, but if 10 people connect, the performance should be good. But if like 500 people connect, it should also still remain functional, responsive, and useful actually. Just to give you an idea, we have like flexible infrastructure on our backend, and if capacity is needed, we automatically spin up more instances as needed. And what you will see is that things can escalate quite quickly. So imagine we have a big live stream session that is happening somewhere in the world with like over 10,000 participants. Then of course we get some pre-warning that such a big event is happening. We can go even bigger, but we start spinning up a few of these services ahead of time, so that once they come in, it's usually an avalanche of people coming in, but that we are ready for that. So and that everything keeps on working. The real-time data processing is also important because there are some choices that you can make in the network level communications, but also in the codec and the way that you distribute your video content in a live streaming situation. Because you can imagine, we all probably know HLS, that's HTTP live streaming. That is a format that is developed by Apple. And you have RTMP based streaming. They have different benefits, different drawbacks. But one of the things is very important when making this choice is how current are people watching your stream. So you can imagine if you're watching a live sports event together in some sort of a live stream setting, and you can actually have the situation that you are watching and somebody 2 seats over is watching the same feed. You want to be like pretty much on the same second while watching this, because it's no fun if you're watching and one of you goes like, yes, they scored, and then the other person goes like, hey, what? Oh, they scored. You don't want to have that happening, because it kind of ruins the effect and the experience that people will be having in that case. But also, if you have like a bigger time cap, you have some event happening, people start posting on X, and somebody else watching the same content is seeing, oh, okay, so apparently something happened, because all of a sudden there's a surge of posts on social media coming by. Oh, there it is. So you want to be making sure that what you are doing is actually current and also delivered on time. Content delivery is also very important, but that's more of a service side effect, because people have avatars, people have like images that they share. You want to make sure that that's taken care of as well, but that's not really part of the video live streaming. And of course, these security and data integrity, they're important as well, but to be honest, yeah, if you're a security geek, it's very exciting, but in the context of video, it's less exciting. But it is something you want to make sure that you do right and that you take care of. And with the scalability and load balancing, resilience and failover is also important, because if for whatever reason one of your instances is having issues, you want to make sure that the rest of your system is as unaffected as possible. So you can imagine if you have a live streaming session with 10,000 people, and some service fails, you want to make sure that for like the majority of the people in the live stream, there is no issue. But of course, if a server falls over, you have to do some reconnecting, and probably the people attached to that server will see some glitching. But hopefully, if you implemented things right, they will reconnect to a different instance and can keep on watching the service that you are providing them. So when you are doing video live streaming, there's a number of architectures, basic architectures really. This is like the most simple images you will see. but there's some architectures involved that you can choose between. So one of them is a peer-to-peer situation. It's basically every participant in the video call connects to all the other participants in the video call. Very simple, very straightforward, but complexity escalates quickly because this is one of these factorial problems. So it's fine with 3 people, but imagine the number of lines that you're already seeing if you would have 10 people participating in the video call. Of course, to get around that, you can get a central component involved. And it's actually, my memory is now actually telling me, okay, so what is an MCU again? Does anybody know what an MCU stands for? Yeah, that's a multiple connection unit, I think it was. I actually have to quickly look this up. But what it involves is that you actually have a single central service that everybody connects to, and they put all the video feeds together and send that out to all the participants. So this scales much more linear compared to the mesh network that we have, but the drawback is still that all the video is being forwarded from one participant to all the other participants. And the question is, so there's not a lot, multi-point control unit. Thank you, Ganesh. And the drawback of this is that you are forwarding all the video feeds to every participant that is participating to the video call. Are there any limitations to the number of participants that you can have with an MCU or a peer-to-peer connection? I reckon technically you would say no, not really, except for CPU, bandwidth, and those kinds of things. So it's really dependent on what kinds of hardware you are running, how far you can take these approaches. Because with a P2P mesh network and an MCU, so the multi-point control unit, what you have is that all the computing and all the complexity is mostly happening on the client, because the MCU in the middle, it's just a forwarding agent. It just gets something and it sends it to everybody else. So of course the MCU will be in some way network constrained, because that's the first resource that will run out. But it is relatively lightweight work that needs to happen there. And then of course, what you could do is move a lot of this logic to the MCU. So what you then get is what is called a scalable forwarding unit. The benefit of an SFU is that it has better scalability compared to a P2P architecture, because there's fewer connections and fewer forwarding happening between all the participants. Because why is that? What the SFU also does is make a selection in what video feeds get forwarded to which participants. So you can imagine in a live streaming situation, there's one talking head. In this case, it's a very clear example. It's me. You're getting my video, but I'm not getting your video, even if you would provide it to the network, because my browser, of course, I'm interested in seeing all you people, but because my browser does not express an interest in receiving the video feed, the SFU decides, okay, we're not sending the video feed. So that already takes care of a lot of superfluous network activity that doesn't really need to happen, because nobody's watching that feed anyway, right? Also, an SFU is more cost efficient CPU wise compared to an MCU architecture, because what you can also do on the SFU is, for instance, if one participant is using a small device, small screen, they don't need like a 1080p feed to end up on their device. So it's better that the SFU actually takes care of this, what's called transcoding of the original feed to something that is more suitable to this participant. And of course, if you have multiple participants on a smaller screen, there's no need to do this transcoding multiple times for each individual participant. You can just do it once and then send the result to multiple interested parties. So you can imagine you have people watching on big screens, small screens, devices with a lot of power, devices that don't have a lot of power, but you can send them a video feed that is suitable for their constraints, their situation. Also, what you can, of course, do in these cases, if you notice that there's lag, latency, or issues happening, you can also, if you take the right video networking protocol, you can actually decide to make sure that a certain participant, because their network is bad, that they get a lower frame rate, a lower bandwidth, a lower resolution, or whatever feed of the video, so that not only can they stay up to date with what's happening, but they also can see something that is still functional for them. Of course, you want to make sure that it's all still legible. So there's some constraints you need to work in, but you can actually be a little bit flexible with what you provide people. And this is something that you probably in a video call have experienced yourself, because for instance, you're in a video call with somebody and all of a sudden one of the participants, their resolution goes down. So they're less clear on the screen. And that's an effect of an SFU at play, because they actually decide, okay, there's network issues, there's CPU issues. We need to make sure that the complexity of this computation that needs to happen for this participant, that is reduced, or that the network footprint needs to be reduced. So we make sure that we downscale or whatever we do to make sure that it keeps on working, right? So that's something that's called asymmetric bandwidth, because the SFU needs to have like a crazy amount of bandwidth, of course, as much as possible. But the participants, they don't need a lot of bandwidth. And with a multi-point control unit, of course, everybody needs to have like a progressively bigger network connection to be able to actually receive all the video that needs to end up on their device. There are some disadvantages of an SFU architecture, and me going so much into details on SFU, you probably can already tell that this is part of the approach that we at Stream are using, and that we've developed on. And there's actually some more things you can do with an SFU. But the thing with SFUs is that there's probably a little bit more latency, because there is stuff happening on the scalable forwarding unit, because it's doing things that takes time. So time is latency, and you have to make sure that things happen quick enough to make sure that the latency isn't either progressive or like a nuisance to the people participating. Also, because there's a lot of things happening on the SFU, the scalability of an SFU is limited. Scalability in the number of participants, because each participant that is added, especially if they have a different profile than other participants connecting, it adds to the workload of the SFU, because with 3 participants, it needs to forward some video feed. Maybe it needs to transcode the video feed into one different format. But if you're dealing with like 20 or 100 people connected, you might be like transcoding it to like 5, 6, 7 different formats, and transcoding is a very computational process. So you can imagine that an SFU at some point starts breaking out a bit of a sweat, because it's just too much, right? So when do you use an SFU architecture? In general, the conclusion that we had at Stream is that you don't want to run a basic SFU architecture. You want to make sure that you run what is called an SFU with cascading, and I will go into that a little bit more after this. But there are some conditions that an SFU in its basic form might still be suitable. And that's if you want to run a single SFU and you want to have full control over it. All the users are geographically close together, so they're basically in the same city or the same country, depending on how large the country is. And the number of users on a single call is relatively small. So if you have like 10 participants, you can probably get away with having like one single SFU. As I already mentioned, there's something that is called SFU cascading. And as I described in the previous section, a basic SFU architecture is connecting all the users to a single video stream. Every individual receives all the video streams that are relevant to them. This doesn't consider users that have a lower bandwidth footprint, in the way that if the requirements of the video stream are full resolution, they still end up at all the participants, no matter how large your bandwidth is. So, and the problem with a slow user connected to a single SFU, so if you're connecting with 5 people and one of them is on a really slow connection, things can get difficult, because what the SFU will start doing on the network level, that's a really low level, the video that's being pushed down this network pipe that is too small, it starts buffering. Buffering takes memory. At some point, there's packet loss, whatever, network issues. The SFU gets saturated at some point, and all the participants will get to deal with the consequences of that. So the problem is, of course, if you are having these network conditions, WebRTC as a protocol has ways to deal with that, but this has an impact on how the SFU is running. And the way that you can get around that is that not only can you have a single SFU, what would happen if you have multiple SFUs? There's a before we go further, there's like one question by Sujit. Where is the SFU located, and how easy to instances communicate with it? Well, actually, I have that on my next slide. It's wherever you are, because with having like multiple SFUs, one of the things that you can do is actually make sure that you have many SFUs across the world, and that these SFUs connect to the people that are near this scalable forwarding unit, and you can actually even have in a geographic region have multiple scalable forwarding units. So you can actually have in I think in Mumbai we're running like 30 or 40 of these SFUs for all the people that are connecting in that region to our infrastructure. And what you can then do, because it's something you need to know if you work with AWS, but the AWS regions and locations that you have available with AWS, Amazon Web Services. So that's for instance, Ireland, India, Mumbai, San Francisco, New York. These regions, they all have a very heavy, big, dedicated network pipeline that is maintained by Amazon themselves. That it even goes thus far that Amazon owns some of the network cables that are on the ocean floor and that are run between these data centers. So you can imagine that the connectivity and the speed and the capacity that you have between these AWS regions is, well, let's just put it that it's quite large. And we take the benefit as an end user of this by using a service provider that has their SFUs geographically located in these regions and connecting over the backbone provided by Amazon. So what this means is that we can go with SFU cascading, and what that means is that you have a group of people that are connecting to a single SFU, and that SFU is optimizing things for these participants. But then the bigger frame video feeds are sent to other SFUs that also have people connecting with an interest to the same video feed. So you can imagine if you have 10 people across the world, 5 of them are in New York, 5 of them are in Amsterdam. They each connect to their own local SFU. That SFU optimizes things for these 5 participants in Amsterdam and 5 participants in New York. And the actual person providing the video feed is in Mumbai. This person in Mumbai sends his video feed to the data center in Mumbai, and then from the data center it gets sent to the data centers in Amsterdam and New York, and making sure that that the best quality is provided worldwide. And then on a local level, things get downscaled. Is it similar to like what you have with Amazon S3 and CloudFront? So you have like edge locations? Not quite, because if you use CloudFront for static content distribution on a worldwide scale, you can actually push things out to what is called edge locations. And those are actually instances that are, or actually regions, so like data centers that are much smaller, but much closer to your end users. And because of the amount of computational complexity that you have, you can't run those on these edge locations. So you have to stick to the bigger data center regions that Amazon provides. At least that's our conclusion. So the advantages of an SFU cascading is that you have lower latency between the participants and their respective SFUs. Also, the reliability is much better because the distribution of load is dispersed across a number of instances. Of course, you have some complexity to manage these instances and making sure that everything stays upright, and if there's an issue, that the SFU gets recycled or replaced. All networking infrastructure, and if you are into these kinds of things, if you're like an infrastructure nerd, you can go really far with this stuff, actually. And it provides better scalability, better load balancing, and you can do optimizations that are very local. So if there's some machine translating that you need to do, you can imagine that if you are in the Netherlands, in the Amsterdam data center, quite likely you don't need to run a Portuguese translation for that data center, unless somebody connects to the Amsterdam data center and expresses an interest through a Portuguese translation. But you don't need to do it if nobody's interested there. But maybe at the other side of the world, in Brazil, you have some participants watching. They want to have like a live transcript running. Then you can do it in a language that is relevant to them. Of course, SFU cascading has a bunch of drawbacks as well, because it's complex and it has a little bit more latency compared to the most simple version, which is P2P. So basically, what that means is that you can do like the simple version of video calling. You can do a little bit more of a complex, so you have to have a central server, that's the MCU here on the left, or you can make it even more complex, move some of the computational load to the central service that you're running, and beyond that you can do the cascading thing. And that's just a little bit of the things that you get to deal with if you implement a video backend. As I mentioned, Stream is running over 1,000 instances in AWS, because there are things like stun and turn signaling service. There's ICE SDP, session discovery protocol, session description protocol. And then, of course, in the end, once you have everything negotiated and you are connecting, you're actually using the WebRTC media stream APIs. And that's when you actually get to sending the video. Just a little bit on the stun and turn signaling services. What does that mean? If you are, we are all familiar with your home router, right? So all the services all the gadgets that you're running in your home, they can all connect to the internet, but the internet cannot connect back to your things in your home, because your router, your internet device that you get from your internet provider is preventing that from happening. So that's there's some network address translation going on. And you can imagine, if you have different peers behind something resembling a firewall, they need to be able to connect with each other, but they can't see each other because of this network address translation going on. So that's where a stun server comes in, and then what that does is actually facilitate the discovery. So every participant connects to the stun server. The stun server connects everybody, and provided that a WebSocket connection, indeed when it works, provided that the WebSocket connection can be made between the participants, the stun server steps out and leaves it to the participants to actually do the peer-to-peer connecting when it's needed. If that's not possible, then the turn server comes in, and what the turn server does is make sure that it's actually just a relay. So it's basically, you tell it to hey, send this message to participant B, and then the turn server turns around and says, sure, I'll send it to participant B, and then participant B says, oh, can you send this back to participant A? And of course, that's also you get around like the firewall in that case. But you can imagine all the things that get involved, because if you look here, ICE and session description protocol, it's all stuff that you need to take care of when you are actually working with video. But this is just a little bit of an overview of what are the complexities of the backend. So now try and get a little bit more to the front end. And this I'm going to keep like really simple, because, well, how can I keep this simple? I don't know. But we have the Stream SDK, and we take care of all the stuff that I just described on the back end, but all the stuff that happens on the front end, we take care of in code, in Swift code. And Swift code is what I think everybody in this call understands and loves. So that means that with our SDK, which is available online, you can just have a look. You can just scroll through our code and just have some incline on what you can actually do to implement your own WebRTC implementation. So, and then of course you want to make sure that things perform, that latency remains low within your code base, that you actually know what's what within your code base, and that you don't get confused with that at least that you structure things well. So if you look at the Stream SDK, it's your very basic 5-layer implementation. So we have a presentation layer, which is SwiftUI UIKit based. We have an application layer, domain layer, infrastructure layer, and integration layer. So presentation layer, as I mentioned, we have a SwiftUI Kit and a UIKit SDK, and there are some controller classes or views that are involved, and a lot more classes, of course, but I needed to keep things simple. And what you will see there is that this takes care of everything in the UI. Then you need data, right? So the controllers, they make sure that processes, states, that those are managed, because you can imagine if you have a call, you need to make sure that the call, it goes through a number of phases, because the call is created, participants are invited, participants are added, the call is performed, things like that. And all that data is embedded into view models, because we actually use a MVVM model, I think, in our SDK it's called. So we have view models that represent the data, and the controllers, they manipulate the data. Next to that, we have some lower level things going on, because if you look at the Stream SDK, you have like the front-end SDK, which does a lot of the things that are specific to UIKit or SwiftUI. And we have the low-level client. And the low-level client is, we have a clear split between the two. And the low-level client really takes care of all the things that are more or less network related. And to communicate between these two layers, we actually have a domain model. And this domain model is actually where things like a call are described, and where a stream video is described. Then at the infrastructure level, you have like security tokens, you have things that parse network traffic. For instance, like the session description protocol, that's a specific networking format, pretty much something on the same level as HTTP. Something comes in on the network, you need to interpret what it actually means, and then based on the interpretation, you need to do something and send a response back. And SDP is just another protocol. But we need to parse that, so we have a parser for that. And then, of course, the backend integration, the token management. Token management in this case is like more the expiration of tokens, and the backend integration is like the networking level things that we need to take care of, because certain protocols, they require a TCP connection, others require UDP. There's also things that we need to send over, of course, TCP, but embedded in an HTTP request. So those are things that we have on this lowest layer, on what we call the integration layer. As we all know, as iOS developers, there are some unique challenges that you get to deal with on a mobile device, right? Because we all know the app lifecycle, the constraints that brings, because certain things can't run in the background on an iPhone. The lower level access to networking and media APIs, a lot of it is available, but just you need to know your way around, because you can do very low level networking if you want to, but you need to make sure that you call things in the right way. Of course, there's video encoding. Some of the encoding formats are available out of the box from Apple themselves, but there's certain encoding formats you want to make sure that they are performant, and but you have to use a library for that. But then you need to make sure that the library uses the metal shaders and all those things that are available on your iPhone, so that it happens battery efficient and quickly. Then there's network restrictions and latency. That's like typical for any small mobile device. We all know the App Store policies, right? I'm not going to go into that too much. And then next to the video part, usually there's a chat component attached to that. So there's like some real-time networking and connectivity going on. And then, of course, you build your app. It's all amazing. It works on the latest SDK. And then there's the end user using like a 5-year-old iPhone, and he wants to be a participant to the call as well. Good luck with device compatibility, right? So this is all taken care of in our SDK. And considering the time, because I'm just talking too much, we're already approaching 10 minutes left, and we want to have some time remaining for questions. I'm going to quickly stop my screen share and present my entire screen. So don't worry, I'm just flipping things around a little bit, and then I share it again. If I'm correct, you can actually see my desktop now. Yes, there it is. And one of the things I wanted to show you is stream video. So I have it opened in Cursor. So we have the README. Well, let's just show that in a fashion that is a little bit better why is that not showing up in front? There it is. If I go to, where's my, I'm having some issues typing actually. So we go to GitHub. There it is. So we go to GitHub. Is this still visible? Yeah, there we are. I lost the feed, I thought. So if we go here, we have stream. Don't take any pictures, please, people, because there are some private repositories here. Nah, no worries. So we have like GetStream as an organization on GitHub, and we have like a bunch of Swift repositories available there, if it is actually filtering. And one of them is Stream Video Swift UI Video SDK Stream Video. There's also a chat SDK, or if you want to look into that, also Swift. This is Swift UI based. This is Swift UI and UIKit based. So, oh, and I need to refresh my recovery codes. Thank you, GitHub. So if you look there, you can go to this public repository. Link will be at the end of this session, and then all the code, all the implementation is available. But this is a lot, right? So how do you actually make heads or tails out of this code base that is like tons and tons of work, that is already 1,300 commits in, and last commit was yesterday, and people are actively committing to this every single day? Well, one of the things that I find very useful is to take something that can take a bunch of source code and then run an LLM against it. And that's like, this is Cursor. And I'm told by my colleague, Stefan, that you can also run this with Olama and do some things locally that you can actually, without paying like an arm and a leg, you can also interpret these kinds of things. So what I like to do when approaching a new source code is to just say, hey, tell me what this code does. And then I make sure that it runs across the entire code base. It does a bunch of scanning, and fortunately Stream pays enough to Cursor to make sure that it's actually something useful. So, and then it is already giving you a lot of information how you can get started. But this is about the source code. Okay, so what are the components I should look at first? Question mark. Then it gives you some information there. And just read that. And then you go like, generate a mermaid JS diagram explaining the architecture to me. And then make sure you do a code level. And now things gets interesting. Based on the provided README and other context, here's a mermaid diagram of whatever is in this thing. So it gives you an explanation. And then you can just go like, okay, let's copy this. I go back to my browser. And then I go to Mermaid Live. Paste this in here. Okay, so what do we have here? So we have the Stream Video SDK. There's UIKit SDK, Swift UI SDK. There's a low-level client. Already it's telling me what I told you earlier. There's a low-level client involved, which does something with calls and stream video, and the Swift UI SDK does something with call modifier, view, factory, and appearance. UIKit does something with the call view control. That sounds pretty much like something that you would do in UIKit. Okay, let's go back to Cursor. And with this help of an LLM, you can do a lot of exploring in your code base. I'm not going to generate them all here, but if I go to Notion, and for some reason it always shows me the login page, I don't know why, and I go to the prep notes for this session, I've actually, to just give you an idea, So it can just generate this. What are the architectural layers? Okay, what are the main components? What does the communication layer look like? Because that was mentioned here. The communication layer is like right here at the right of this image. And then, okay, you get a detailed overview of that. And okay, so what's the sequence diagram of creating a call? Of course, it's generated, it's AI, so you have to make sure that you actually double check that it's correct. So it's good to have somebody available. You can ask a question or two, but I checked this and this is all correct. And I've noticed with sequence diagrams and these kinds of diagrams, cursor is pretty much spot on all of the time. But do make sure to double check yourself, because it would be silly if you come to some kind of conclusion and it's actually a some sort of fantasized information from the LLM. And you can just also zoom in on what WebRTC does, what are the peer connection factory bits, and oh, by the way, this is a nice feature of Notion. I don't know if you knew this, but you can just take this mermaid diagram and you can just take a code block section and select mermaid, and then you actually get this split view. This is the initial view, and then you paste it in, and then you say, yeah, I just don't want to look. I like pictures. I'm a simple guy. Okay, this I understand. Nice feature of Notion, by the way. So getting back to our slides and wrapping things up, because we only have 5 minutes remaining, and there was so much else I wanted to talk about. I'm just doing this quickly in my browser. Yeah, so if you go into the stream source code and you want to look at some of the really cool low-level things, and I'm sure we can. Yeah, there's my notes, and this is actually stuff I wanted to talk about, and that's make sure that you look at the stream pixel buffer pool, the adaptive video capture policy, the call kit adapter, and the local video media adapter, because those are some of the things in our code base that we do non-obvious things on a low level that are interesting, to put it like that, and interesting in the way that it's novel in the sense that it's not what you would normally do, right? Normally you would just like, okay, some high level video API, and we do this, and something happens on the screen. Yeah, but now we do the same thing while using like 30 or 40% less CPU, because we load things into the metal shader parts of the CPU. And that's really cool, because that's when you actually get to experience the true power of a mobile phone like an iPhone, because everybody says like, yeah, these devices are powerful and they're amazing, but once you start like using these vector engines and all these kinds of things within a mobile device, you will be blown away with what this small thing in your hand is actually capable of. And you actually also have the same or similar hardware available on the more modern Android phones as well, if one of you is actually an Android fan. So because we are running out of time, and I still want to have some time left for all of you, I have some useful resources here, and I'm sure that these links will be shared afterwards. If you want to dive more into WebRTC, because I only touched the surface, I scratched the surface, we have a whole free, you don't need to do anything, you don't need to sign up, you can just click on it and you can start reading, and it's great. That's the what we call the WebRTC for the Brave resources. And Devon, who is like a shadow participant of this call, is one of the main authors of that. And yeah, he did like a great job, and he's actually refreshing the content right now to make sure that WebRTC is described in a way that people can just get some inkling on what it's actually doing. Because WebRTC, people think it's, yeah, that's something like with connecting video and everything, but there's a whole lot of stuff happening underneath that needs to be done right, that needs to be implemented to make sure that you can actually have a successful video call. And in this WebRTC for the Brave resource, we also have, for instance, one of the bits of code that we have in there is like a description of what the SDP protocol does and how you implement it, how you actually implement a stun server with nodes, with like just a little bit of code. It really shows how simple this thing actually is. So definitely check that out. If there's anything that you take away from this entire session, make sure to check this first link on this slide here. Second of all, of course, we have a video SDK. There's a link there as well. You can pretty much find it. We have amazing tutorials using our video SDK with a free sign-up that you can actually experience video live streaming, video calls, and all that kinds of stuff. And most likely you've actually experienced our platform before this video call, but you just didn't know about it. But I'm not at liberty to share too much information about our corporate users because I'm not a salesperson. Other resource mentions is of course Mermaid Live that allows you to render Mermaid.js images, Cursor I showed. And if you want to get connected with us on LinkedIn, you can find Stream, you can find me. On YouTube we have a really neat channel that we have videos on that basically take you through the tutorials and a whole lot of other things to really expose you to what is possible with video. We're doing a lot of fun things with large language models there as well. And we are also on X and probably also on other social platforms, but these are the main ones. And now I basically want to ask Miang to help me out here because it's now time for questions and answers. And I only got through like half of the information I wanted to talk about. Wow. I hope I did okay.
That's awesome, Yuran. I think that was a very value-packed session. I know that you were in a hurry also in the later part
Yeah.
because we limited time, but the resources that you have provided will definitely add more value to whatever you explained today in terms of the topics that you covered. And thank you so much for doing that. And to all the people who are currently with us on this session, guys, I think for the last 1 year, we have been focusing on mobile system design a lot. And you guys have been quite interested in understanding mobile system design because it's a core subject, so to say. And everyone has its own approach of understanding system design of a certain, let's say, system. And today, Viran told us about the live video SDK. In the same sense, we have covered other subjects as well as far as other systems are concerned. And if you want us to bring more such valuable sessions in the coming future, make sure you check out getstream.io, because without any collaboration with a great SDK like a Stream SDK, we would not be able to bring out these valuable sessions to you. I don't think that anybody has yet done a great session like this one on only SDKs as far as live video is concerned. So once again, we thank Stream to be able to do that with us, and being very humble with whatever our demands were in terms of collaboration and the cooperation that we required for this session. And without any further ado, now let's head on to the Q&A. And for that, I would ask Ahmed to please proceed ahead with that.
Yeah, definitely. Thank you, Jeroen, for this comprehensive overview for live video system SDK. Guys, if you have any questions, please share it.
I've noticed one already, because one of the questions was somebody asks, why do we have two SDKs? And this I can answer in two ways, because if you would look at it that way, we actually have 6 SDKs, because we have a chat SDK and we have a video SDK. That's 2. But the chat SDK, we have a UI kit and a Swift UI flavor. And the video SDK, we have a UI kit and a Swift UI flavor. So we actually then already have 4 SDKs. But underneath both of these flavors of our SDKs, on both sides, we have a chat low-level client and we have a video low-level client. And why do we do that? If you're doing a UI kit implementation, you don't need to get involved with any of the Swift UI stuff. Other way around, it's pretty much the same, unless you want to pull UI kit things into your Swift UI code. But with the Stream SDK, that's not necessary, because these 2 SDKs, both on video and UI kit, they have feature parity. So what you can do in UI kit, you can do in Swift UI and vice versa, at least visually to the user. Also, we have the low-level client, because in some instances, you don't want to do all the fancy UI stuff the way that we like to do it. You might actually have such specific requirements that you do want to use our service and you do want to have a lot of benefit over SDK, but you want to do your own UI. And that's why we have our low-level client, and that's why we make this split both on the chat end and on the video end, so that you as an end user, you have a choice. You can choose, I'm going to use Swift UI. You can choose, I'm going to use UIKit. And you can choose to do whatever you want yourself. And even beyond that, you can even forget about our client-side SDKs and connect to our API directly, because we have REST documentation on everything as well. Good luck implementing that, because it'll take some time, but you have the option and the opportunity to do that if you want. So I hope that answers your question, Jaya.
Yeah, write another comment about he means a separate Swift UI and UI kit.
Yeah, that's, as I mentioned, that's because if you use Swift UI, you don't get to deal with the UI kit, because I don't know, if you're using Swift UI specifically and you only pull in one bit of UI kit, there's a lot of added complexity and a lot of stuff you have to deal with, and we don't want to put that as an SDK provider on you. It's a choice that you as a SDK user get to make, whether or not you're implementing a Swift UI. Do you want to get the added stuff of UIKit? Well, that's something that you can decide on your own, and that we do not force upon you because you just happen to use our SDK. Another one that I noticed what was very interesting was something about like, okay, so you have a video call coming in, and when the app is closed. That's by Ahmed. Yes, true. That's a thing that you get to deal with. And we have a tutorial. We might need to refresh it a little bit, but that's where CallKit comes in, and you can integrate you can integrate our video SDK completely with CallKit, and that basically means that your app is in the background, and something comes in, a notification comes by, and then you get like the typical calling interface that you are used to if you're an iPhone user. So you get this ringing effect, you get like this screen that you can influence how it exactly looks. But everything you can do with CallKit, you can do that in combination with our video SDK as well. So you can actually build like a video calling implementation if you want, that's like fully compatible and similar to, for instance, something you can do in WhatsApp.
Yeah. Also, we have another question, Dimitri asking, what does the low-level access to a network mean?
Yeah, well, of course, if you are using, I'm sorry, I'm a UIKit guy. So if you're using URL session, it's quite easy. You create a URL session, high level, you basically define your request and you send it, right? But if you want to do like things on the TCP or UDP level, because you either have to implement your own protocol or you have to implement a protocol that is still on top of either UDP or TCP, but you need to make sure that you can actually create your own messages. That's what you can do. But also in some cases, you want to program things at the socket level. And there's not a lot of instances that we need to do that in our SDK, but that's the level of low level that I mean. Because if you want, you can really on iOS, you can really go to the pretty much the Unix level of network coding, and that means that you start coding, you allocate something, all memory management is gone, and then it's like, okay, get me a socket. Okay, I got a socket. Now I'm going to write to the socket. The lowest level networking that you probably have learned in Network 101 in university, you sometimes need to do that, and that's the level of low level that I'm talking about. Ahmed Barakat has another question. In live streaming, is there an option to have multiple participants as streamers? Yes, you can. There is some complexity, of course, involved there, because you have like a small number of video sources going out to a large number of viewers. But you can, the way that we do live streaming in video is that you, one of the ways actually that we do that is that you connect on an RTMP, I think it is, but you connect to like a URL with your video source, and you can pretty much do whatever in your video source that you'd like, and then send it into your live streaming audience. But you can also do that on the server side and do that on a coding level, so that you can actually, you would get a bit of a separate system, but you would then be muxing together several video feeds and sending that as the reference feed for everybody to watch.
Perfect.
As a streaming SDK, we can understand that it will use a lot of memory and energy. How are you keeping check of this, like monitoring and improvements on it? Yeah, so we do. We have a quite a substantial suite of automated tests running. So definitely, if you're into automated testing, definitely check out our SDKs because we do a lot of it. And one of the things there is like we monitor what is the network footprint, what is the memory footprint, what's the CPU intensity, so the battery drain that we are causing. And anytime that we see large increases in that, we investigate why that's happening. Sometimes there's a valid reason for that because something is like just taking is something that's like that computationally intense. But sometimes it's just something that we figured out. Yeah, well, we need to do this, but there must be a better way, a more efficient way that we can do this. And sometimes that involves what I like to call just taking a shortcut. But for the end user, the effect is the same. In other cases, it's like it's gloves off, and we go low level, and we do like really crazy stuff on with metal shaders, and then it's like something that would take like seconds on the CPU. It's like a blip on the metal shaders for your phone, and that's what I mean. But some things, especially video, you can do crazy amounts of work on one of these iPhones, and the iPhone itself is not even breaking a sweat because of it. But if you do the same work on the CPU, your battery is dead. So yes, we keep an active eye on that, and also if customers raise an issue in this area, we are very keen on investigating and figuring out what in their use case is causing this increased load, and then we try to figure out if this is something that we can circumvent or something that we can code away or whatever. But we are actively we are actively monitoring this with all kinds of measures, and that we recommend anybody doing live streaming implementations to do similar things on their implementation, because you can only do like if you make a small mistake relatively coding wise, it's not even a logic error, but you can kill the battery of your end user, and you don't want to be that app, right? Anyone else?
Okay.
One more question, maybe. Oh yeah,
Yes.
one thing that's performance related is what we also mentioned in this section about SFUs, is that we use the best possible codecs for each participant in the call. So that's really dependent on your device's capability and resolution and everything. And we pick a codec that is most efficient in your use case. And what defines most efficient? That there are some dials that we can of course try to adjust, but usually it's like the least network and the least CPU given the conditions that we go for. Another question by Ahmed is record supported where client side or server side? Yes, recording is supported. Of course, you can implement it yourself on client side. That's easy. Well, let's just say you can implement that, and we can help you like how you can efficiently implement that. But we also support recording on the server side, and then the recording on the server side, it gets recorded and then it gets processed, and then once the recording is done and processed, you get a notification on a WebSocket which allows you to immediately automatically pick up the resulting URL, or you can manually do that through our dashboard. But recording is supported on the server side. So that means that you have some options to actually indicate, so I want to record my live stream, or I want to record individual participants. You have different options available there depending on how you are implementing this. And of course, if a recording happens, this gets broadcast to all the clients, and then in your implementation, I find that to be like a decent way of doing things, but you get the opportunity to respond to that and actually display to your end users that a recording is in progress. Because you wouldn't want to be sneakily recording somebody's screen without them knowing, I would say, because you don't want to be the person picking their nose on a live feed, right? And also the recordings that we have made, you can also query what is available for a specific session through an API. So also if you do a client implementation, you can, it's flexible what you can do. You can actually like get these recordings on your screen and then click on them and work with them. But it's all a bit dependent on how you implement things. So I think that was the last question. So let's wrap it up because we're already 15 minutes late. And we probably all have other things to do as well today, like finishing up some work or getting ready to go home, or maybe you are even already home and you're aching to get dinner. Maybe it's like late at night for you and you need to get to bed. It's all possible. So Mayank, it's up to you to close things off. And everybody, thanks for watching and thanks for listening. And I hope it was useful. And definitely check out the resources that we shared on the final slide.
Perfect. Ahmed, would you like to go ahead?
Sure. Thank you, Jerome, for this comprehensive overview and for answering all the questions. And thank you all for your attendance. We would like to know your feedback. So if you want any specific topics, please write to us. Also, tomorrow we'll be sending an email for your feedback. So feel free to share any thoughts so we can do our best to do more sessions that can be valuable for you. Thank you all for your attendance.
Awesome. Thank you, Ahmed. And thank you so much. A big shout out again to the Stream team for those who joined late. This event is in partnership with Stream SDK. You can check out getstream.io. And thank you so much to Yuran and his team, the whole team of Stream, for bringing this together with Swift Anytime and putting this into a form that people can understand live video streaming. Because I have seen people getting scared with these big topics when it comes to, let's say, Amazon Prime, streaming, and Hotstar streaming, Disney plus Hotstar streaming, and then you talk about Netflix. People get overwhelmed with the streaming things whenever it comes to videos. So thank you so much for making it quite simple today for everyone, Yuran.
Yeah.
And we believe that we will be bringing more such value to the community in the coming future by partnering again. And for those who have watched this session, once again, Ahmed has already mentioned that we would be looking forward to your feedback. So make sure you reply to our email tomorrow, because your feedback will decide if you want more such sessions or not, and if you like this one or not. Fingers crossed. And with that said, I will just let you guys close the session here and do your respective work, just like what Yuran said. And thank you so much for taking out time for the session to everyone, including Yuran, to you as well.
Yeah.
And
yes,
yeah.
Ahmed Barakat, the feed that you're getting is adaptive.
Okay. So that's the last question that Yuran just answered, but that doesn't stop there. You can just spam his LinkedIn maybe, and you can just go over there, because I believe he would be responding to all of you. Maybe it will take time because you might, come up with a lot of questions, but make sure that you reach out to Yuran and his team. I think he would be able to figure everything out for you as far as your doubts are concerned with video streaming. So having said that, thank you so much once again, guys. I'll see you next time with such interesting sessions. And for that to happen, you have to support us just the way you supported us today. And just take care and have a great day ahead. See you next time. Bye-bye.
See you. Bye-bye.